Okay, it's 2:11, so let's get started on, let's go over the problems, all right? So for the first one, who wants to explain how to do number one? I'll give you more space. Any volunteers? Kaden, your hands up. So Claire, listen carefully. Kaden, can you go over it slowly? I want
Okay.
those, yeah.
First thing is that you multiply 11 by 2.
Mm-hmm.
Then you multiply 2 by 11.
Yeah, what we're doing here is getting a common denominator on the bottom, right? So we can get the same number on the bottom, right?
Then you multiply the top.
Mhm.
Then you write this. Do you add it? Then you add, then it's 40, 22.
All right, just a bit of a tiny mistake right here. 1 times 11 right here. 1 times 11, this should be 11, right? So this number should be an 11. So the answer
Oh,
should
yeah.
be 29 over 22, right? Right, thank you. I'm just gonna go over it in a bit more, and I'll just go over it again. Right. So what Caden did is he first multiplied the first number, or the two denominators, right? We have 9 over 11 and 1 over 2, or 1/2. So you just multiplied the bottom number, right? So to get 22. So we create two new fractions that have a denominator of 22 at the bottom, right? So because we want the denominators to be the same. Now we just need to convert 9 over 11 into something over 22, and then 1 over 1/2 into something over 22. So how can we get from 9/11 to something over 22, right? So Claire, you know that to get from 11 to 22, we need to multiply by 2. And now we need to do the same thing on the top, right? So we also multiply 2 up here. So the question mark will be 18. So we can just put that here for now. Now we do the same thing for 1/2, right? We also need to convert that into something over 22. So 1/2 equals question mark over 22, right? This time we multiply by 11, right? To get from 2 to 22, we multiply by 11. And then now we must do the same thing on the top. So 1 times 11, and this will be 11. So now, remember, as the denominators are the same, now we can just add straight across, and it'll be 29 over 22. So is that a bit more clear now on how we do this? A bit more? Okay, good. That's okay. Good job. So if you need help, just remember, ask, and I'll help you as best as I can. All right, so let's continue. Now into the negative numbers, right? This is where the tricky stuff happens. Okay, so number 2. Can someone explain how they got their answer? Anyone? Claire, how about you? How'd you get number 2?
So on 6 and 9 there's two negative signs. So if there's two, then it creates a positive sign. So you just do 6 times 9, and that's 54.
Let's remember, when the signs are the same, it's positive. When the signs are different, it's negative, right? So let's say we have negative 6 times 9. This will be negative because 9 is positive and negative 6 is negative. So we have two different signs. In this case, this will be negative 54, right? In this case, we have two negative signs, so the signs are the same. So we will get a positive 54 here. So does everyone get that? Okay, good. So now for number 3. We have 3 numbers here. So how can we do it with 3 numbers? Um, let's see. Dennis, how about you?
Okay, let me. Okay, and okay. For the third one,
Mhm.
it says
says negative 5 times 9 times negative 2. So first I did negative 5 times 9, and then negative 5 times 9. Oh, you already drew the equal sign. Okay. Negative 5 times 9 is negative 5. No, I mean 5 times 9. And then 5 times 9 is 45. So you do a 45 here. Let me see. 45. Now you can't do 9 times something now because we already got 45. So now instead of 9 times negative 2, it's 45 times negative 2, which equals, so let me see, 45 times negative 2 is, let me see the work I did here. Okay, so 45 times negative 2. Okay, let me get this. Okay, hold on. Gotta move this. Okay, there. Now I can do it. Okay, so 45 times 2. 5 times 2 is 10. So here, and then 4 times 2 is 8, and then since there's a 1 here, 8 plus 1 is 8, so it's 80.
Are you sure it's 80?
Let me see.
So 5 times
90?
Yep, 90. There we go. 90. Right. And then now what? Are we done?
And then now, since we got our answer, hold on, let me re-annotate. We got 90, but then since there is a negative sign there, I think we put a negative sign.
Okay, good. You're very close though. So you made a small mistake, but it's okay. More practice when we get it. So first, negative 5 times 9. So should that be 45 or negative 45? Negative 5 times 9.
Negative?
Yeah, it should be negative, right? So, right, there's negative 5 is negative and 9 is positive, right? So when you have different signs, we should have a negative 45. Do you see that?
Yeah.
Okay, so now what should the final answer be?
Now it should be this.
90, right? Positive 90. Okay, good. And you have a negative 45 and a negative 2. So we have two of the same
Because
signs.
there's two negatives.
Exactly, two negatives, so they're the same, and we can make it positive, right? Also, this is not a mistake really, but just in case, we can maybe put parentheses around this to make it a bit more clear that we're doing 45 times negative 2, not like 45x minus 2 or something like that. Okay, good. So who wants to do number 4? Anyone? Let's see. Angela, how about you? Do you want to try number 4?
Yeah, I'm not that good at it.
Do you have any guesses? Any ideas, maybe?
I think it was something about. Oh, wait a sec. Is it 14?
Yeah. So how did you get 14?
So you know, they did actually. I learned a little bit about this. And
Mhm.
also, two minuses equals like adding.
Exactly, right? We have a double negative here. So when you have two of the same signs when we're subtracting, right? That we have two negative signs, we can just change that into a positive sign, right? Two equal sign or two of the same sign, we just add instead and get 14. So this is a bit confusing, but the more practice you do, the easier it get, right? So it'll become 8 plus 16 because the signs are the same, right? So negative, or we subtract it and it's a negatives. So this is called a double negative, right? So 8 minus negative 6. We'll just change it to a plus sign. Okay, good. Let's see. For the last one, Alan, how about you? Do you want to try this one?
5.
Yeah, number 5.
So the perimeter of a triangle is 13.1 centimeters, and then the two sides are 5.9 and 3.4. So then 5.9 plus 3.4 equals 9.3. And then 13.1 minus 9.3 equals 3.8. So then
Is that your final answer? 3.8?
no, that's 9.3.
Mm-hmm.
And then 13.1 minus 9.3 would be that would be 3.8.
Yeah, I was just kidding, but I just wanted to remember the units, right? It should be 3.8 centimeters. I was just kidding. Your answer is right, but I was just kind of testing you, right? Okay. So good. So what Alan did is he first added up the two sides of the triangle, right? 5.9 plus 3.4. Remember, the key is to line up the decimal point, right? So now once the decimal points are lined up, we can find that the two sides of the triangle added together are 9.3 centimeters. Now we take the total perimeter. The perimeter is all the sides of a shape added up, right? So that's the perimeter. And then we subtract it, right? So 13.1 minus 9.3, right? And to get the final side, which will be 3.8 centimeters. So does anyone understand this process there? Thumbs up. Good. Or instead, we could have just subtracted them twice, right? So 13.1, we first subtract 5.9. This will give us 7.2, right? I don't want to just show all the work, but we can just subtract them one at a time, right? And then 7.2, and then we subtract 3.4 again, and this time we'll get 3.8, right? So it'll give us the same answer, but we can do it two different ways. Okay, good. So now let's move on to let's go back to negative numbers, right? So let me clear everything actually. So for those who didn't watch the video, um, remember I said that there was a mistake on numbers on scenarios 2 and 3. Who remembers I said that? Who remembers that I said that? Okay. So I was actually just confusing myself. This is actually correct. The logic here is actually correct. But I for some reason I just like confused myself. So yeah, sorry for confusing you guys. So I guess we just have to do more practice to kind of remove the confusion, I guess. So scenario 1, does everyone remember how to do this one? Adding a positive number. Let's just do an example really quickly. 7 plus let's say positive 8. Everyone just quickly just type the answer in the chat. What do you get here? Let's see some participation. We have 2 people so far. Seven plus positive 8. Or just 7 plus 8, I guess. Okay, so this is just B15, right? This is there's no tricks here. It's just yeah, thank you. 7 plus 8 equals 15. Good. So remember, when the signs are the same, we can just add straight across. Okay. So now let's get back into scenario 2, right? I crossed it out last time, but let's go over it again. It's actually correct, all right? So adding a negative number, right? So we have 5 plus, let's say, negative 6, all right? So what do you guys think should be the answer here? Okay, good. Five plus negative 6. Kind of have to visualize this, I guess. Just kind of think, should the number get bigger? Should it get smaller? Okay, negative 11, that is a good guess, but negative 11 is close, but not quite. Okay, good. So the answer to this is actually negative 1. Okay, so if it was negative 5 plus negative 6, this will be negative 11, right? So we're starting from negative 5 and we're going even smaller, right? So that will be negative 11. But in this case, we have a positive 5. So no, Kaden, you didn't type negative 11. Someone else did. It's okay. In that case, Kaden, how are you? Can you explain how you got negative 1?
Because it's a high negative number than the positive number.
So that's a good way of thinking it, right? Think about it. So negative 6 is if on the number line, it is farther away from 0 than it is from 5, right? So you have to go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 instead of 1, 2, 3, 4, 5, right? So there's more on the negative side. So I guess you can think that it becomes a negative number. So that does make sense, but let's approach this systematically, right? So remember, when the two signs are different, we just make it a negative sign, right? This also applies to multiplication, but like, I guess in a different way. So we can just change this into 5 minus 6. And remember, I taught you that when we have a small number first, we can just flip it around. 6 minus 5 equals 1, and then attach a negative sign to the front. All right. So is everyone good with that? Thumbs up. Okay, good. Thank you. All righty. For scenario number 3, so right, subtracting a positive number. So this is where I got confused last time, but it was correct. So let's just go over it again. So I don't really want to confuse anyone. So we have 7 minus 7 minus positive 8. Okay, so what do you guys think? Again, think about the signs, right? Think about the signs. Negative 1, positive 1. So we have two different answers here. Two different answers here. Which one is correct? Negative 1 or positive 1? Okay. Okay. Okay, so for a lot of you, the signs are a bit confusing, right? So the answer to this is actually negative 1. Good, negative 1. So a lot of you put positive 1, but I understand that. So remember, yesterday I thought I made this mistake as well. So it's okay if some of you get it wrong, right? So here, let's think about it this way. So positive 8, what is that the same thing as? 7 minus 8, right? It's the same thing as 7 minus 8. So you don't, sometimes the plus signs really mess you up, right? So you really have to just think about the problem. The plus sign in the parentheses, these are new things to you, so I understand. But remember, when the signs are different, right? So you see there's a minus sign here and a positive sign here. We just go into 7 minus 8, right? And this should be negative 1. Let's do another one since a lot of you were a bit confused on this one. How about 8 minus positive 5? So I guess the first thing you can do is rewrite the problem. I think that's always really helpful if you rewrite the problem. Let me actually make this bit clear. 8 minus positive 5. What do you guys think? Okay. Negative 13. That is interesting. Not sure how you get negative 13. That is just take another guess, right? Positive 13? No. So we're getting some. So we have here are all the answers we have. We have 3, we have negative 3, we have 13, we have negative 13. So it's kind of all over the place right here. So who is confident in their answer and wants to explain? Who is confident? Alan, you're confident? Okay.
Yeah.
So,
So
what do
it's basically just 8 minus 5.
exactly. So what do we get here?
That's 3.
3. Good, right? So again, you can think of it as positive. When you see a positive sign, I guess you can just kind of remove it when it's inside the parentheses. So this could be just 8 minus 5 or just 8 minus 5. This would be 3, right? Or alternatively, you can look at the problem and see that the two signs are different. So instead we could just do 8 minus 5 right away and we get 3. Okay, very good. All right. Let's finish this up quickly. I kind of do want to get into algebra. Okay, so last scenario, subtracting a negative number. So 8 minus negative 7. Okay, so what do you guys think? Okay. So yeah, negative signs are tricky, right? It's okay if some of you if you don't get it right the first time, but yeah, they're pretty tricky. 8 minus negative 7. What do you guys think? Okay. Look at the signs, right? Looking at the signs is really important. What should we do when the signs are the same? What should we do when the signs are different? Okay. So that's just something more. All right, good. So the answer is actually, I know Elijah, you weren't here on Monday, but it's actually 15. All right. This might be confusing, but when the signs are the same, positive. Okay, positive. So it's the same thing as scenario number 1, right? When the signs are the same, 8 plus positive 7. When the signs are the same, it's just 8 plus 7, right? The signs. It's always remember the signs. Okay. So in this case, this is again the double negative. Oops, I cannot draw 8 minus negative sign. It's called double negative, and it just becomes 8 plus 7. Okay. So now we'll come back to this, right? But for now, let's move into a new topic, and this one is algebra. So who has done algebra or maybe heard of the word algebra before? So some of you, okay, cool. So let's get into it. Okay, and again, same signs means add, opposite signs means subtract. Or multiplying and dividing negative numbers. Actually, let's do this first before we get into algebra. Let's do a few problems just to refresh your memories. Okay, so again, same signs, different signs. When it's same signs, it's positive, different signs, it's negative, right? So let's do a bit of a review. 6 times negative 2. What do you guys think? 6 times negative 2. Okay. Yeah, my handwriting's a bit messy today, but okay. 8 times negative 2. If you're not sure, it's okay. Just take a guess. Negative numbers are difficult, right? So remember, I got it wrong yesterday or on Monday, so even I mess up sometimes. So it's okay. Just take your guesses if you're not still not sure. Okay, we have some 12s. We have some negative 12s. Okay, so the correct answer here is actually negative 12, right? So this is a bit confusing, but remember when the signs are different. So the sign of 6 is a positive number, right? 6 is a positive number. And negative 2 is a negative number. So here, the two signs are different. So we have a plus and we have a minus. So in this case, our final answer will be negative. Okay. Remember, we'll just need to do more practice to make sure we get this. Negative 9 times negative 3. What do you guys think? Negative 9 times negative 3. Remember, same signs positive, different signs negative, right? So think about it for a little bit. Okay, we have some 27s, we have some negative 27s. So which one is right? Okay, so the correct answer here is actually 27, right? So it's going to be a bit confusing, but it's positive 27. I mean, it's a bit confusing, but look, same signs, right? If you have a negative sign here, oops, I meant to write a negative sign here. We have a negative sign here. So the final answer should be actually positive. So this is a bit confusing, but remember, same signs, right? We have two of the same signs. We have two negatives here, and that will finally return a positive number. So this is a bit confusing, but that's okay. Remember, more practice, and we'll get better and better at it. Okay, let's do one more. So let's try negative. Okay, let's do a combo, right? We're gonna do a combination. Negative 3 times negative 5 times 2. What will that give us here? This one's tricky, all right? So, what do you guys think? Kaden, check your work. It's not. Okay, there you go. All right. This one's a bit tricky, right? Just take it step by step. Take it step by step. Remember, the signs are the key. Pay attention to the signs. Same signs or different signs, opposite signs. I should say opposite signs. I think opposite signs is a better way, right? A positive and negative. If they're opposite, it should be negative, right? But if it's the same signs, it should be positive, okay? So we have some 30s and we have some negative 30s. Which one is right? Think about a little bit more. 30 or negative 30. Okay, so let's see. Elijah, how about you? I know you weren't here on Monday, so negative numbers, this is a bit new, but let's see how you do it. I want to see how you're getting your answer. All right. So what do you think?
But can I end the thing?
Yeah, go for it. Definitely.
Okay.
You see the back?
So first it was 3. So I know that the 3 is it's a minus 3, so that means it is a negative. So 3 times 5 is 15. I already know that it's still a negative because both have a negative. And then 15 times 2 equals 30. but it still have the negative on it. So that's how I know a negative 30 because there wasn't no positive in the equation.
Okay, so that was a good try, but it's actually the answer is actually positive 30. Here, I'll explain why that is. So look, I keep saying that, but more practice, right? But negative, when we have two negative signs, right? So let's say we have -3 times -5. This should give us positive 15. Okay, so when we have two negatives, right? Two negatives will make a positive. Two negatives make a positive, right? So when the numbers are the same sign, we have a negative here, we have a negative here. Our final answer should be positive, right? So this is a bit tricky, but the more and more practice problems you'll do, the better you'll get it, right? So -3 times -5 should be positive 15, and then we just multiply by 2, and that should just give us 30, all right? So that's why it should be positive 30. Can I see a thumbs up, sideways thumb from everyone? Okay, thank you. All right, let's do one more, right? So do another composite or just like a multi-step, I guess. -4 times 2 times 3. Let's try this one. Just let me know in the chat. I will get some water. Be right back. Okay, good. So everyone said -24. I'm proud of you all. Okay, good. It's -24, right? Because -4 times 2, that's -8, right? Because only they're opposite signs. -4 is negative, 2 is positive, and then we just multiply by 3, and it's still one opposite signs, right? One's negative, one's positive, and we get -24. So good job, everyone. Surprised everyone got it right. So that's amazing. All right. So now let's get into algebra, right? So we don't have much time left, but let's just introduce you guys. So algebra, it's the area of mathematics where symbols and variables are used to represent numbers, right? Some of you may have seen X, Y, Z, A, B, C. You can pretty much use any letter or symbol for a variable, right? Okay, so by using variables, we can solve a lot of problems without having to guess, right? Remember, we have that sheep or the pigs and chickens. If we use algebra there, we don't really have to guess and work our way to the answer, right? So algebra, we can use the algebra for many things, right? Pretty much everything today that involves like technology, or maybe if you want to build a rocket to go to the moon, if you want to construct a building, all of these needs algebra, right? So for example, let's have an example. So we'll 3x, all right? So x in this case, this might look like a 3 times, right? This might look like 3 times 5, but in this case, we'll use x as a variable, right? A variable. So maybe I'll just draw these squiggly lines so you know that it's a variable, right? So 3x. So what do we want x to stand for? Maybe x equals the number of hamburgers that we buy. Okay, the number of hamburgers that we buy. And $3 a hamburger, right? So we have we buy an X amount of hamburgers. So X can be anything, right? We buy 1 hamburger, 2 hamburger, 10,000 hamburgers, right? We can make X anything, right? But the hamburger costs $3. So 3 is called a constant, right? So it's not a variable. It's just a regular number, and this is called a constant. So 3x so equals P. And so can someone tell me, what do you think P is? So we buy X hamburgers that cost $3 for each one. What do you think P should be? Elijah, your hands up.
What the hamburger stand for?
What did you say? I didn't really hear you.
What the hamburger stand for? P.
The hamburger. Okay, close. Let's see. Alan, how about you?
It stands for 3x.
Okay, yeah, it stands for 3. Okay, so Kaden actually messaged me. It's how much all the hamburgers cost, right? So how much the cost of all the hamburgers that we buy. So let's say each hamburger costs $3, right? But if we buy, let's say 5 hamburgers, the total cost will be $15. So do you guys all understand that? So P will be the total cost or price of all the hamburgers that we buy. Okay, good. So let's say, what if I make x equals 7? So what would be the total price of all the hamburgers? So let's set, we buy 7 hamburgers and each hamburger costs $3. So what should the price be in this case? Everyone let me know in the chat, right? So let me know in the chat. Good? So you buy 7 hamburgers for $3 each, right? Each hamburger costs $3. Good. So it should be 21, right? So this is where algebra comes in. So we can just plug the 7 into the x here, right? So we just do 3 times 7. Okay, so let's bring in a new notation, right? So a dot sitting in the middle. It's not like a decimal point. The decimal point is like at the bottom, but instead we'll put it towards the middle, and this will stand for multiply, right? So 3 times 7. So this dot, we'll learn a new symbol here. It's called a dot. We use a dot so we don't get confused with like variables, right? The x looks very much like a multiplication sign, so instead we'll just use a dot for now. All right. Right, so 3 times 7, and this will return us 21. So the good thing about algebra is that we can just change the amount of hamburgers that we buy without really having to change the overall equation, right? So we can use the same equation for any amount of hamburgers, right? So let's say we buy 100 hamburgers. So now what will the price be? Or the total cost of all the hamburgers? If I make it 100 now, we buy 100 hamburgers. Okay, good. Remember, each hamburger costs $3, right? So that's why we have that 3 here. Good. So it should be 300. Good. So we put that in here. So 3.100, 3 times 100. This will equal 300, right? So does everyone kind of get like this basics of algebra here? So thumbs up. Okay, thank you. All right. So now let's get into something a bit more complicated. So now I'll give you 3x, and now I'll give you the total cost, right? So total cost is 18. So we know that each hamburger costs $3, but we spend a total of $18. So first tell me, what are we looking for in this case? What are we trying to find? Elijah, what are we trying to find?
We're trying to find how many hamburgers did you buy from the $18.
Exactly. Good. So now what should that be? What should the answer be here?
The answer is, wait, do we gotta type it in the chat?
Oh, you can just tell me. So first tell me what the answer is and then how you got it. How you got the answer.
So the answer is 6.
Mm-hmm. So how'd you get that?
How I got it was I did multiplication from 3 times 8. I started from 8 and counted it all the way down from 3. So 18, 13, no, 15, 12, 9, 6, 3, and then 0.
Okay,
So
that makes sense. Good, right?
that was 6.
Good. So now we can do this without guessing, right? So this is another part about algebra. So we can solve a lot of problems without having to guess. Some of you, maybe we could try 5 hamburgers first, maybe 7 hamburgers, but now you can do this without guessing. All right. So let's get into isolating the variable. Okay. So this one's a bit tricky. All right. So to solve algebraic equations, we must put the variable on one side by itself, also known as isolating. To do this, we must use the rule to do something to both sides of the equation. This way we can keep it equal. So let's say let's just start with 2 equals 2, right? So can everyone agree this is true? This is true, right? 2 equals 2. Good. So we can do stuff on both sides. So let's say we add 3 on both sides. We can add 3 and add 3. So we're doing the same on the both sides. We're adding 3 on both sides, and this will still give us 5 equals 5, which is still true, right? So this is still true. Let's say we start with do 2 equals 2 again. This time we can multiply by 5, right? So multiply by 5 here. We can multiply by 5 here, right? We have to do the same thing on both sides. And this will give us 10. 10 equals 10, which is still true, right? 10 equals 10. So now, let's say we have 7 equals 7. Let's say we multiply by 2 here, multiply by 3 here. Are we allowed to do this? Do you think we're allowed to do this? No, good, right? No, we're not allowed to do this because we're not doing the same thing. We're multiplying by 2 here, multiplied, so this is not the same. So we'll get 21 equals 14, and we all know this is not true. Okay, good. So the same logic then applies to algebra. So let's look at x minus 9 equals 5. So let's say we have an unknown amount of apples, okay, so which is x. And now we eat 9 apples and we're left with 5. So this, everyone get how I set up this equation? We first start with x amount of apples. We don't know how many apples we have. And then this will be x, right? So this is what we set our variable as. So this is x. And now we're quite hungry, so we eat 9 apples, and then we're left with 5. So how many apples did we begin with? What do you guys think? Let me know in the chat. How many apples did we begin with? Started with, we don't know how many we started with. We ate 9, and then we're left with 5. Good. A lot of you got it right? It's 14. So 14 minus 9 is very easy, right? Everyone can see that 14 minus 9 equals 5. But we don't want to guess, right? Sometimes maybe we try 13 first and then 15, maybe 16. We don't want to guess, right? So now we must do isolating the variable. So how do we isolate the variable? Isolating the variable means we get x onto one side while we have all the numbers on the other side. So we want x to be by itself. That's what isolating means, right? Maybe if on an island in the middle of the ocean, you're isolated from everyone else, right? Because you're the only one on the island next to no one. That's what isolating means. Okay. Now, how can we solve it then? So remember, we have to do the same thing on both sides. We want to get rid of the 9. So how can we get rid of the 9? We have minus 9 here, so we can add 9, right? So negative 9 plus 9, this is equals 0, right? Does everyone understand how negative 9 plus 9 equals 0? Does everyone get that? Kind of? Right, so we want to move it to the other side. So now we must do the same thing on both sides, right? So we also have to add a 9 on the right side. So do you get what I'm doing here? Right, I want to get rid of the minus 9 on the left side, right, to isolate x. So I do it to both sides, right? We must do it to both sides. Now after we do that, we have x negative 9 plus 9, right? That's equals 0. So x plus 0 equals 14, right? 5 plus 9. And we don't have to add 0. X plus 0, that's the same thing as x equals 14. So does everyone kind of get what I did here? I know it's a bit hard to understand, but kind of sideways thumb, maybe upwards thumb. How do you guys think about this process? Okay, let's do more practice, right? I know some of you are a bit shaky on this. Let's try x plus 3 equals 5. So I don't know how many apples I have, or we have a mysterious amount of apples right now. Someone gives us 3, and now we have 5. So how many do we start with? So Okay. First, let's give everyone some time to think about it, and then Elijah, I'll call on you in a few moments. All right. Okay. So Elijah, what do you think? What should we do here?
The amount of apples, the number we started with was 2.
Mm-hmm. Okay, so let's see. Dennis, how about you? Do you have any ideas? What should we do here?
Um, we have to. Do we have to see what plus 3 is 5?
Yeah, exactly. So what would that be in this case?
That would be 2.
Good. So does anyone know how to do this algebraically, right? So we want to move, or we want to keep x on one side and all the rest of the numbers on the other side. Does anyone know how to do this algebraically or using algebra? Alan, you want to give this a try?
And you subtract 3.
Good. So we have to subtract 3, right? So we want to get rid of the 3 on this side, so we must subtract it, right? So 3 minus 3, you all know that's 0, right? So what we do on the left side, we must do on the right side. So we also have to subtract 3 on the right side. You see, I'm doing the same on both sides. Remember, let's say we have 2 minus 2, or 2 equals 2. So we must, if we want to like subtract 1, we have to do the same thing on both sides, and we get 1 equals 1, right? So same thing applies here. So now 3 and negative 3, we can just cancel these out, right? Because they'll give us 0, and we can't really do much with 0. So this just becomes x. And on the right side, we have 2, right? 5 minus 3, that will give us 2. So does everyone kind of understand how we did this using algebra? Kind of. Sideways thumb. Okay, sideways thumbs. A lot of sideways thumb. Okay, that's okay. Let's do more practice. We have time for one more. All right, so x plus 4 equals 2. So this one's a tricky one, all right? So I want everyone to just try to solve this one, and then once you're done, let me know in the chat. We don't have much time, so just everyone just take a guess if you need to, right? So take an educated guess. And always when you're done, when you're finished with the problem, you can always double check your answer, right? So put it back into the equation and then see if it works, right? Okay, so we have some 2's, we have some negative 2's. So which one is it? Remember, once you're done, you can always plug it back in and see if it makes sense. Okay, we have some negative 8's. Interesting. Wait, does anyone want to share how they did it using algebra? Using algebra. Claire, is your hand up?
I swear.
I mean, my way isn't the algebra way.
Okay, that's okay. Yeah, I'll just explain this because we don't have much time. So we want to get rid of the negative 4 on the left side, right? So how can we get rid of the 4? What we need to do is subtract 4, right? We want to get rid of it. So 4 minus 4, and that'll just give us with nothing, right? So you just cancel this out, and we must do the same thing on the other side. So 2 minus 4. So what is 2 minus 4? This should be negative 2, right? So because 4 minus 2, we flip it around, and we just add a negative sign, right? So for those of you who answered 2, you can always double check your answer, right? So think about it a little bit more. If we plug in 2 back in, we get 2 plus 4 equals 2. That doesn't make sense, right? Because we get 6 equals 2, and this doesn't make any sense, all right? Okay, so good job, everyone. So that is